Hello there, welcome back. Welcome back to the third session on Oracle architectural explanation. Let me share the screen. So we have been doing this one, just did a walkthrough on the architectural component which belongs to Oracle database instance. So now you know at least the terminologies, the wordings, right? Still we didn't get the definitions. So now let's try to get the definitions. So let's go to the next one. So this is going to be the definition. The very first thing is instance. So we know what is instance by now, collection of memory structures and background processes. So if you go back, you can see again, we have collection of memory structures, MMS, that is what. What are memory structures? Now you know the key memory structures, shared pool, database buffer cache, and redo, PixSTA, and optional things are. So all together, collection of memory structures plus background processes known as the instance. That is very clear. Okay, right. The next one is HCA. HCA, we know now, system global area collection of memory structures. That is very clear now. And shared pool consists of library cache and data dictionary cache. If you go back, shared pool consists of library cache and data dictionary cache. Okay, so what is the purpose? Let's try to get that one also as an extension to the definition, even though it is not given here. So library cache is what? Library cache is mainly holding the execution plans of the previously executed SQL statements. Library cache. Because in Oracle, whenever an statement is going to get executed, let's say it's just a select command. I'll be coming back to this one in more detail, but I'm just telling you briefly. So whenever there's the SQL statement is involved, so what's going to happen? Oracle has to do something called parse, fetch, and execute. There are 3 steps. So parse means what? End results of the parse. Parse also going to certain sub steps. We will learn it later. End results of parse is what? Execution plan. So what Oracle does, these execution plans are preserving. He's preserving the execution plans for future usage. There are reasons for that. We will learn those things. Cache, hit cache miss, hard pass, soft pass. Those things are there. So let's learn it later. But the whole purpose is preserving this one. So where is going to preserve? Preserve means that it store somewhere. No? So it is storing in the library cache. So execution plans will be storing in the library cache. Execution plans are nothing much. How to execute this statement? It will be taken now by the optimizer later. There for a statement, there can be many execution plans. So the base execution plan will be taken now by the optimizer, then only push into the next step. So those things we will learn later. But for the time being, library cache will maintain execution plans. Then data dictionary cache. What is data dictionary cache? Now we know Oracle has a data dictionary which is located where? In the system DBF file. System DBF file, it means in a data dictionary. Now what is this? This is a cache. This is a cache from that. Because DBF file is on the physical memory in the disk. So I mean we can't be always fetching those things. IO operations, always doing IO operations means it's getting slow. So what Oracle does, it maintains a cache from the underlying system DBF file, prefetch area. So that is maintained in the data dictionary cache. So what is in the data dictionary cache? The content extracted portion of data dictionary from the system DBF file. There is a reason for this, because to generate the execution plan, it needs the support from data dictionary cache. Because part of the execution plan, if I just tell, it need to know, let's say if a particular select statement is asking a particular table and there are a set of columns. So when you say, let's say select item number, item name from item details table, Oracle has to know whether this item number belongs to this item details table or not. So for those verification, it needs to refer to their dictionary. So instead of going to the data dictionary in the disk, what Oracle will do, it will look at this data dictionary cache, which is in the memory, system global area. So let's do that work through in more detail later, but this is a definition. So as a definition, Data dictionary cache will maintain what? A prefetch area from Oracle system DBF file. It will maintain a cache from system DBF file. Fine. Let's go to the next one. What is the next definition? It is given. DDC. It is given what I just explained. Data dictionary cache, which is caching data from Oracle data dictionary, which is from system DBF file. Already explained. Library cache. Again, it is given. Library cache, where this is stored execution plans of the previously executed SQL statement, where this is stored execution plans of previously executed SQL statement, right? Library cache, that is what. So that's also explained previously SQL execution plans of previously executed SQL statements. Okay. Okay, that is clear. Then the next one, we are coming flashback buffer. Did you see that in our this one? We have flashback buffer. This one. As soon as you see that in this color, the light green color is for optional. That's what I have given everything in that color. Light green color is for optional memory structure. So flashback buffer is optional. It's all optional. Optional. So it is also explained here. Is an optional component in the HCA when flashback database is enabled. And I think we will learn it later. What is flashback database? Just to logically revert the changes done for the database. There is only one feature. There are many features of flashback, like flashback, query, and a lot of things are there. Let's learn it later. But then again, it's optional one. And recovery writer. Recovery writer is the process which is responsible for writing data from flashback buffer to FLB file, because FLB files. Because when you run the database in flashback mode, by default database is not running in the flashback mode. If you run the database in flashback mode, we need to enable it. Once the archive mode is enabled, you can put the database into flashback mode. So once you enable it, flashback buffer will get started and recovery writer process. Because changes from the database buffer cache will be pushed to the flashback buffer. Not everything, because there's a different mechanism. It is not time to explain that, and I'm just telling. Then from the flashback buffer, recovery writer process will write those things to FLB files. FLB files. So we will learn it later. It is not the time to dig into everything. This is, we are going to definitions. In memory, another optional area. It's an optional component that enables objects to be stored in memory in columnar format. This is Oracle feature. We know columnar format is there for optimization. Again, we will learn it later. Columnar type is data type storage. Right? It is a optimization for analytics, columnar. And then comes large pool, another optional memory area intended for memory allocations that are larger than is appropriate for shared pool. That's true. I mean, certain memory components cannot be occupied in large shared pool. Example, when a shared server is configured, the UGA, user global area, is being moved from the shared pool to large pool. Shared pool to large pool. So that is why, because whenever larger memory is required for components in the shared pool, it will be pushed to the large pool. Not everything, but UGA is just example. We'll come back to that one in more detail. Large pool, it will be explained in more detail later. So still the definitions to be complete, because there are a lot of definitions we need to take. MemOptimize Pool, you saw that, right? MemOptimize Pool, we have it here. This one, this is in memory, optional. MemOptimize Pool, that is also there. That's another memory structure. What is MemOptimize Pool? Row store, MemOptimize row store improves the data query performance of applications such as Internet of Things that frequently query tables based on primary key values. So it's a specific area optimized for these type that frequently query table based on primary key values. So that's if there are queries which are querying data always based on primary key. So you can define MemOptimize area. So Oracle will utilize that one in order to optimize the queries. Let's learn it later. For time being, just get the definition because I don't want to miss these components. These are important components, even though optional. Depending on the production requirement, you have to introduce these things. That's why I am just giving the definition in architecture. So depending on the requirement, let's elaborate it later. Redo log buffer, compulsory one. Redo log buffer. It's a compulsory, not optional. It's a circular buffer in the HCA that holds the information about changes made to the database. Of course, due to the DML commands, not only DML, even the DDS, whatever changes happening in the database will be tracked in the redo log buffer. This is mainly for recovery purpose. Now, don't confuse this one with rollback information or undo information. Undo is something else. It's also tracking the changes, but undo will maintain the old image, no, the whole record will be maintained. But in redo, that is redo. Undo is one thing, redo is another thing. Redo will track only the change. If the salary field modified from 1000 to 10,000, it will keep a track of only that column modification, not the whole record. Undo is something else. Again, undo is for rollback purposes. Undo is for rollback purpose. Redo, we will learn later for roll forward purpose. Rollback and roll forward are two things. In Oracle database, we talk about roll forward as well in order to recover it when a crash happens, maybe instance crash. We will learn it later, right? So definition, I think you understood. And UGA, user global area, again optional. User global area, session memory for the shared server and Oracle XA interface used when transaction interact with multiple databases. So this is for shared server. So for the time being, let's keep it. UGA will be explained in more detail later. Fixed SGA, very important, fixed SGA, not optional, compulsory. Containing general information about the state of the database and database instance and information communicated between processes. Yes, so you saw that, right? In this output, if you take a look, now fixed SGA is there, this one, fixed SGA. To maintain the status of the various components and the background process, you need that fixed SGA. Oracle allocate this memory at the time of instance starting, and it will maintain it. Okay, let's continue. Then you have Javaful, again optional, is used for session-specific Java code and data in the Java virtual memory, virtual machine, actually, Java virtual machine. Java code and data, it is used for all session-specific Java code and data in Java virtual memory. Anyway, if you are using a specific Java front end, and you better enable this one so that you can optimize it. But again, optional one initially. If it is not Java, no, optional. Streams Pool is also optional. Is used by Oracle Streams, Data Farm, Golden Gate, integrated capture and apply process. Optional. We'll talk it later. Definition is that. Share IO pool, that's another optional one, is used for large IO operations on secure file large objects. LOB is secure file large objects. Shared IO pool. Specific situations, we can enable those things. Go to the next definition answer. Let's finish the definitions in this session actually. Definition: request queue. Dispatcher places the request on request queue in the large pool. Yes, dispatcher. This is in the shared server environment. Shared server environment, we have request queue and response queue also there. I think the next one we have the response queue. You can see after request queue is completed, the shared server process places the response in dispatcher's response queue in the large pool. Each dispatcher has its own response queue. This is nothing much when the connection is established. We will learn it later. Earlier I told you the user process and the server process, because by default Oracle use the dedicated server processes. And we can configure the shared server process as well. So if a shared server process is configured, then multiple users will be sharing, multiple sessions will be sharing a single server process, that is shared server process. In the dedicated environment, one user will always get the attention of a one dedicated server process. But in a shared server process, multiple user sessions will be getting the attention of one shared server process. So in a shared server environment, you're going to have the response queue and request queue. because request queue is what? The incoming connections by the listener process will be queued in order to be verified by the database server. Once verified, it will be put it back to the response queue of the relevant dispatches. Because not like in a dedicated connection, listener can right away talk to the server process. Server process means Oracle server process. Whereas in whereas in the shared server environment, listener has to go to another process called dispatcher in order to talk to the Oracle database server. So we learn that from more detail under session establishing. We'll be learning on session establishing, how a session is established. So we'll talk that on more later there, but for the time being, just take a look at the definitions. Request queue and response queue. You can just do something like that. Select server from $. Yeah, let's check that. Select server from $. Session. That is what. Here we go. This is what. Now this is because because each background process also it takes as a session, so that's why it has, even though there are no users working, only myself connected, but you can see a lot of dedicated servers are there. So all are dedicated. That is the reason is this server is a dedicated server. So parameter, yeah. So you can see nothing is configured for shared max shared server. Everything is 0. This is just default. Shared server processions, nothing. Shared servers, nothing is configured. So therefore, this is always dedicated. So by that's a default actually. And middle session, so we can take the SID and further details. Okay, let's check that. All right, so if you want to see more details about that dedicated server and shared server, so you can try out this. You can say select server, I think username, program from $. Session. Yeah, program will tell you whether it's details, background process. So let's tick. Yeah, I think it's given. Yeah, so now you can clearly see we have actually, I have two sessions because I think there's another terminal which is connected. All are from this machine. This is a user session, again dedicated because this server is dedicated. I haven't configured the shared server. And you can see all of others are having connections because each background process there's a connection. This is a PMON background process monitor and other VKTM, memory manager, likewise SC, Jane, diagnose, and SC, likewise all are background process. So all are dedicated. And again, this is another session. So that's why it's a dedicated server. So if it is a shared server, as I mentioned earlier, show parameter shared. So we need to configure these parameters. Shared server parameters are there and dispatchers and no. So let's keep it for a while. I just want to show you practically about this dedicated and shared servers. Okay, so let's continue this one. Yes, so we have been doing here, right? Okay. Response queue and okay, we have the background process. You know, BGP is background process. System monitor. Now we are coming to the background processes. BGP, background process, short name for background process. System monitor, SMON, is in charge of a variety of system level cleanup duties. System monitor, integrity of the system. It will maintain integrity of the system. It is one of the major background processes. PMON, process monitor, responsible for monitoring and cleanup of other processes. Yes, if a user session gets stuck, and display will take care to clean up that process. If it is abnormally terminated session, yes, this one needs to do that. And even if instance crash, this one will come to clean up the processes. And checkpoint CKPT mainly synchronize the control file and data file header with checkpoint information. Yes, very important process. We will learn it later. It is known as the time synchronizer of the database. It synchronizes the control file and data file by looking at the latest SCN numbers in the redo log file. Let's learn it more later. Checkpoint queue and all are there. DB writer process which writes from database buffer cache to data files. Database buffer cache to data files. Just to go back, and this is what we have been explaining now. We can see here we have database buffer cache, and this fellow DB writer writes data from this place to the relevant data file at the bottom. It is not indicated because we will be learning those in more detail. Yeah, as earlier, the checkpoint process. This is the checkpoint process. Okay. So just to give you the definitions, let's continue on the definitions, and you can see checkpoint, DB writer, and log writer. Log writer process writes data from redo log buffer to redo log files. Redo log buffer, redo log files. Okay, so that's a log writer. There's a redo log buffer. We saw that earlier, and there's a redo log file at the bottom in the database. So it creates the link. Mainly, these background processes are linking the physical structure and logical structure. So that is one of the main purposes. Linking the physical structure and logical structure. Physical structure means the database file, which is on the disk. Logical means the HCFA area, which is the main memory part. Keyman process manager oversees several background processes, including shared server, pool servers, and job queue processes. Right, background, it just maintains those background processes. Okay, let's start the rest of the definitions in the next session. I'll see you soon. I think we have done a lot of definitions. So from this place onwards, listener registration, let's start in the next session. All right, thank you very much. I'll see you soon. Have a great time. Bye-bye.